Okay, going on to the additional exercises of Chapter 9, Section 1, Composite Functions and Inverse Functions. And we'll be going through these topics. So as we look at our vocabulary here, composite, horizontal line, inverse, one-to-one. In an function, the output depends on a variable that in turn depends on another variable. Well, this is composite for number 1. Number 2, a function f is if different inputs have different outputs. Well, this is a one-to-one. Different inputs, different outputs, one-to-one. Exchanging the first and second coordinates of all ordered pairs in a random result, I should say in the relation, results in the what to the relation, or what kind? Well, this is an inverse. And if we wanted to see what they refer to here, a very common use of it would be your original was xy. The inverse is yx. That is, you've reversed the coordinates. This is straightforward. This is the inverse. A function f is one-to-one if it passes, we had said, if we saw a graph that looked like that, and we were to bring down across the face of it a horizontal line, and that horizontal line only intersected in one place at a time, we say it passes the horizontal line test, and that's right here. And that indicates it is a one-to-one relationship. Okay, let's go on. Now, as I mentioned, we wouldn't be doing all of these, but we certainly want to go through what is needed to figure them out. Bring that down a little. So here we see we have some compositions of the set A, well, in A, I should say. We're going to deal with set function of f as it is composed with g. And our value for our function here would be 1. And then here we're reversing them, 1. Then again, reversing them, but we're going to use the letter x. And reversing, and we're going to use the letter x. So again, they have it laid out for what the functions are. And again, we're going to apply a 1 there first. So since g is listed first, we're going to take the 1 and put it where x is here. So this is going to be 3 times 1 is 3. Minus 2, that's going to give us a 1. We now take our value of the g function and put it here, where x is 1. So 1 squared plus 5 will be 1 plus 5 is 6. So our answer here is 6. Now we're going to clear this and reverse it, where we're now going to do the f function first. And again, we're saying the f is a 1. So in here, if our x here is a 1, we just said that this was 6. 1 squared is 1 plus 5 is 6. We now put that 6 into this. 3 times 6 is 18. So that's going to be 18 minus 2. So the reverse function here is 16. Now, another very typical function is where we are using x as our variable. So again, we go here to x, and our x will be this. So we will now place this over here. And we go x squared, but we're saying x is this. And then we're going to add 5 to it. So this becomes, square this is going to be 9x squared. Multiply these together, you get a negative 6x, double it, negative 12x. Square this, you get a plus 4. And now we add our 5. So for letter D, then it's not, I should say C, 9x squared minus 12x plus 9. And you recall this was 6 and 16. Okay, we're now going to go on to letter D here. G of F, or G circle F, or G composite F, where we're looking for x. So first, what will our x be? Well, our x is going to be this. We then take this, put it where our x is in the other function. So let's work that out. So that's going to be 3 times x squared plus 5, and then minus 2. So 3 times x squared is 3x squared plus 15 minus 2. So this then gives us 3x squared plus 13 is our end result. In doing example 6, what I've done here is written out the answers. And that's a technique you might go through or use when you're working on something. And again, these are additional exercises. So we're using that same composition up here, and where we're going to use 1 first, and then later for x. So here, if f of g for our first one, we'll look at what g is, and our x value is 1. So where g is, our x value is 1. So 1 over 1 squared is 1. 1 over 1 is 1. So we then bring that in here, that new value 1. 1 minus 6 is negative 5. Now we're going to reverse it. We're going to take the 1, but put it in our f function first. So 1 minus 6 is a negative 5. So this is a negative 5 here. We're then going to put in our second function, in this case it's the g, where the x is a negative 5. And we're going to square it. So we square negative 5 and we get 25. So 1 over 25. That's our second one. Now in letter C, we're going to substitute an x there for our g value. So what is our g value? It will be 1 over x squared. Remember, our x value is this. So it's 1 over x squared. Well, we put that 1 over x squared there, minus 6. So that would be our c value. And then for our d, we want to reverse this. What is our x value? Well, our x value is this. So we're going to put this where x is. So it becomes 1 over x minus 6, the quantity squared. And our 1 stays in the numerator. And then we expand this binomial, square this, multiply these two together, double it, gives us our middle term. And it's a little hard to see that. Let me clear that up just a little bit here. Looked like it was a continuous line. And then we square negative 6 and get 36. So our answers work out very well. And we had here a topic to shoot toward. But again, we're following this procedure. Now, for number 7, again, we're following the same thing. It's f of g, and then later g of f. And we put a 1 there first, and then an x. So, if x is a 1 here, then we go to our g term, or g function first. We put a 1 there. 1 plus 5 is 6. 6 now goes into here where x is. We get the square root of 6. Now we switch this around. We put, this is our square root of x for the f value is 1. Square root of 1 is 1. So over here, this will become a 6. Now in letter C, they want us to put an x for these. So for our function f composed with g, this is going to be an x. So this is our x here. So under the radical sign, this value for x goes under the radical sign. So we have then the square root of x plus 5. And if we switch it around, this is now our x. We place it here, we get the square root of x plus 5. Now, to master these, you're going to have to try some yourself. I'm not going to do them all, but give you an idea of how it works. Okay, let's do this table as we look at it. Here, they want us to find if our x is 1 initially for g. So our x is 1, this one right here, and we go to the g column, which is 0. We then go back to the x column, where our 0 is, and we end up with a 3 for number 9. Now, reversing that, here our x value is 1, but for f. So we go 1. We now go to our f column, which is negative 1. Go back to the x column, negative 1, and then we then go to the g column, which is 5. Now, this is just another way of writing this one here. So we go to our f value where x is 0, 0, and we get a 3 for our f value. We then go into this column, but we don't see a 3 anywhere here. So when that happens, it's not defined. And then now we're going to do the g column, but we're looking for our x first, which is 0. So 0, g is negative 2. We then go to negative 2, and that brings us to 0 for our f value. Okay, let's continue. Now, for this one, we're looking for a function of f, function of g, that's going to give us a composite function h, where we have x as what we want to illustrate. So this is what we got at the end when we had f circle g, and we're looking for what x was. Now I set it up this way so you can perhaps go a little more quickly, but if you want to pause it at this stage and then do some of these on your own, remember this is what we're building, a practice of skills. So what we're saying is this is what we ended up with. So what could have been g? Well, g could have been 10 minus 3x. And if that's your g value, and you put it into this as your x, and then square it, then you end up with this. So your f value could have been x squared. So doing this composition, you're going to put this where x is, and then square the x, which is what this is, to give you that. Now, take a look at this one. So, what's under the radical sign? Well, 4x plus 9. And what do you put here? The square root of x. So if this is your x value of g function, you then place it under the radical sign, which is your function of f. And what do we have here? Well, again, if we put this as the square root of 2x plus 7, and what do we put here? Well, we're going to have 4 in our numerator, and then this will just be x. So if this is our x value, we will put the x value where this x is, and then we end up with the composition, this. And here's sort of a tricky one. But using that same technique, if this is the square root of 5x, then how would you write this? Well, 1 over x minus x. So wherever you have a value of x here, remember this is separate here, you just replace it with this value, 5x, and then you get this. Okay, not too bad. In number 17, we're asked to determine whether each function is one-to-one. Well, first of all, to determine they're a function, does it pass the vertical line test? And this does, and this one does too. So these are both functions. But next question is, does it pass the horizontal line test? So as we move this horizontal line, it passes. So if it does, it is one-to-one. So this one is one-to-one. Now in diagramming a parabola here, again, I didn't draw that too great. It's for illustrative purposes only. Does this pass the horizontal line test? And the answer is no, because it intersects twice here. So this is not one-to-one. So this would have an inverse. This one would not have an inverse. Does this one pass the horizontal line test? No. So this is not one-to-one. How about this one? Yes, it does pass the horizontal line test. So this is one-to-one. And now what we want to do is for each function determine whether it is one-to-one, and if it does have a one-to-one, find the formula for its inverse. All right, so are they one-to-one? This one is. This is just a typical graph where your y-intercept is 1 and your slope is 1. Here your y-intercept is -2 and your slope is 5 over 1. So these both pass the horizontal line test and one-to-one. And this one's the parabola again, and it does not pass the vertical line test. So how do we set these up? Well, we set them up by saying, change this to y first, reverse the letters, solve for y, and then change the y to function symbol. So f inverse equals x minus 1. So this is the standard function, and then this is its inverse. And we solved it by changing the function symbol to a y, switching the y and the x around, and then solving it for y. So we'll do the same thing here. Y equals 5x plus 2. Switch the letters around. X equals 5y plus 2. Now solve for y. Well, we get 5y, x minus 2, divide both sides by 5, and then change the symbol. This will be f inverse equals x minus 2 over 5, and this is not one-to-one. This one's a little tricky, so I'll work it out for you. Here we see our function of g is this. So we're going to change this to a y, which is what I have here. We're now going to reverse the letters, put the x there and the y there, and then we're going to solve by multiplying both sides by y. They cancel on this side, and then I divide both sides by x, and our new y becomes y equals 2 over x. And you say, well, wait a minute, that's what we started with. Yes, its function is the same as its inverse is the same as its original function due to the nature of where the x is placed. Okay, let's do this one together. So this is going to be y equals the third root of x, or x to the third, I should say, plus 2. Switch the letters around. So we have x equals y to the third plus 2. Solve for y to the third, we get x minus 2, y to the third, and then take the cube root of both sides, and we just end up with inverse of g equals the third root of x minus 2. Okay. And for number 26, when we have the function y equals 10, it's a horizontal line. So does this have a one-to-one? And the answer is no. Okay. Doesn't pass the horizontal line test. For number 27, as we graph the function and then its inverse using the same graph, keeping in mind that throughout this, we're going to have the axis of symmetry, which is right here, that will make a dotted line. And the inverse will be the reflection of this. So let me set this up for you. It just takes time to do. So that will be the reciprocal of that, the inverse, by replacing the y with the x and the x with the y, solving for it. So this is the first one in blue, this is the second one in black, and there's our axis of symmetry, which is y equals 1x plus 0, going through the origin. Okay, now for this next one, if you have a graphing calculator, you can do it very well. The answer is in your book, and I'm going to just attempt to sketch them a little bit. So since this is a -4, we know that this is going to come up like so, around -4 here. And its inverse, again, the axis of symmetry is right down through there. It will look like over here, and that goes through, I believe, a 4 up there somewhere. and like that. Anyway, I'm not going to do that in great detail. It's taken us 30 minutes so far, so let's see how far we are along here. And I think we'll pass those up. Okay, we'll get on to 9.2 here shortly.